Welcome to this video on process capability, or CPK. We'll explore how to translate statistical variation into practical business impact, ensuring your processes meet customer expectations consistently. The core question is, what is the probability of our process producing a defect? Process capability is the inherent ability of a process to meet customer expectations without needing extra effort, rework, or inspection. Defining the target involves a requirements lifecycle. First, we listen to the voice of the customer. Then, we translate these needs into measurable critical to quality characteristics, or CTQs. Finally, we specify the bounds, establishing the lower and upper specification limits. Customer expectations can be categorized into three levels: must-haves, which are non-negotiable needs; wants, which offer linear satisfaction; and delighters, which are unexpected features that create high satisfaction. The lower and upper specification limits, LSL and USL, define the boundaries of success. The LSL is the minimum acceptable measurement, and the USL is the maximum. The target is the ideal customer expectation. Any data falling outside these limits is a defect. The capability engine is a continuous cycle. It begins by defining specs based on CTQs, ensuring stability by removing special cause variation, measuring capability to assess performance, and finally, improving the process by reducing variation and repeating the cycle. To measure process capability, three prerequisites are essential. First, descriptive statistics are needed for understanding the mean and standard deviation. Second, process stability ensures the process is in control. Third, normality confirms the data follows a normal distribution. The Six Sigma objective is to shift and narrow the curve. Before, high variation and off-center results in many defects. After, variation is reduced, and the process is perfectly centered on target, making it safe, capable, and predictable. CP, potential capability, measures the spread of the data relative to the specification limits. It asks, is our variation narrow enough to fit within the boundaries? However, CP assumes perfect centering and represents only what is theoretically possible. Cpk, real process capability, accounts for both process variation and process centering. It measures how the process is actually running. The K factor mathematically penalizes the score when the process shifts away from the exact center of the specifications. When diagnosing process health, Cppp assesses potential precision. A low score suggests we need to reduce variation. Cpk/Ppk assesses reality, including accuracy. A low score here suggests we need to recenter the process. Cpk is calculated by comparing the voice of the customer, LSL/USL, and the voice of the process, mean sigma. It evaluates the physical distance from the mean to the closest specification limit, divided by 3 standard deviations, resulting in a single Cpk score. We benchmark success using sigma levels. The minimum standard is 4 sigma, with a Cpk target of 1.33 and a defect rate of 6,210 ppm. The world-class standard is 6 sigma, with a Cpk target of 2.0 and virtually 0 defects at 3.4 ppm. In a real-world example like pipeline coating, Cpk ensures the coating thickness is within limits to protect the pipe without wasting material. If Cpk drops below 1.33, operators know whether to recenter or reduce spray variation, preventing defects. Achieving process capability requires aligning customer needs with specification limits, stabilizing the process, and utilizing Cpk to measure centering and variation. The target is a minimum Cpk of 1.33 to protect both the customer experience and the business bottom line.